Elena is currently a lead data scientist at Meta, focusing on long-term research project in the ad space. Prior to this, she was a data scientist at Amazon and a data engineer at Everest. Originally from Barcelona, her career started at the young age of 7 years old as an elite swimmer, which she did until the age of 19. She's also an accomplished pianist and a recipient of multiple poetry prizes. She's come out top of her class at the University of Barcelona, where she studied mathematics, after which she moved to London to get her master's in data science. Elena, we're very lucky to have you on the show. Thanks for making the time.
Thank you for having me. I'm really excited to be here.
Awesome. So I want to start with maybe to take a little detour and to start with your career as a professional slash elite athlete. So what does it mean to be an elite swimmer so young? And maybe what did your training load look like?
I guess that's what it means when you start any sport directly, kind of at an elite level, is that you train seriously and like you train to achieve certain goals. Like you do it for the fun, obviously, you're a kid, but there is always in the background kind of this idea of you have to compete and like you have to do it well in order to like be successful. It's more than just for fun, I would say. Um, and yeah, like at the end, this just turns out like having a big commitment even when you're a kid. Like you train a lot of hours and a sport almost becomes more important than a school or equally important than a school. So I remember, for instance, when I was around between the age of 12 and 16, more or less, I was training 2 to 3 hours before going to school. Then I was arriving to school and doing a school more or less normal. I was skipping some lessons, but like it was kind of like agree in between the school and my swimming club. And then after school, I was training again in between 2 to 4 hours, depending on the season. So like overall, you are training 7 hours, 6, 7 hours a day, and kind of your life becomes a bit the swimming pool. Like your friends are the people on your swimming team. Your coach is kind of the person that you kind of have a bit like as a point of reference, and yeah, I guess that's what it means to being like an elite athlete fairly early on.
But so you managed to successfully juggle that with what I believe were successful academics, right? Because you went on to University of Barcelona to study mathematics, and the bar is fairly high, right, to just get accepted. So how were you able, at like a young age, to prioritize? It wasn't even prioritized at the end. Like you made time to be successful both at school and academically.
Yeah, I guess the key is you really learn to prioritize when you are really young. You learn which things are important and which things can wait, and you become extremely efficient with your time. I remember like finishing a school like at 4 p.m. more or less, going to trainings until 7 p.m. and then just like rushing to home and maybe sitting in my chair like in my desk from like 7:30 to 9, which was like dinner time. And this hour and a half was of like 100% focus studying. Like I was not procrastinating. Maybe it was easier. We didn't have social media. So maybe it was easier to focus. But I just remember like being really good at kind of like changing from one activity to another and like putting all my effort in each of these activities. And I also think like at my advantage, I used to love studying and I used to love swimming because someone might think like, oh, maybe that's a little bit too much for a kid. They don't think it's too much because you do all these things, both studying and swimming, passionately. Like I love both. Like I've always been a good student and I've always loved studying, and I was a good swimmer and like training at an elite level, but I was doing it because I wanted to do it. So I guess like the key probably is like this word that we listen so much when we are like at work, prioritize. Like I think for kids that start doing a sport at a competitive level fairly early on, we learn how to prioritize our time at the age of 6.
That's incredible. Because I think anyone working in tech definitely like has to learn how to prioritize that at the job. But yeah, at the age of 6, I definitely wasn't prioritizing anything. But so you kind of, to circle back into tech, how, like, have you found any? I guess you found many transferable skills, right? Like this ability to focus, this ability to prioritize, because you've worked your entire career in tech, and so can you talk a bit more about these parallels?
Yeah, that's interesting. I think probably like the main one is that you learn how to prioritize. As I was saying, like that's probably like the main skill I gain as an elite athlete at the same time that I was studying. And I also think you learn how to focus, and you kind of I think you really have a really good knowledge of yourself. You know really well when you need a break. You know really well when can you push yourself a little bit harder. And I have found this to be a really useful skill as a professional. I know when I can be working until late to achieve something because I believe in that and I really can push myself and I can focus on my final goal. But simultaneously, I know my body and I know my mind because I have spent a lot of time with myself. So I also know when I need a break. There is kind of, I think, a component of self awareness that being an a sport like or being an athlete gave me, because all athletes when we train so much we're like really connected, like our mind and our body are like really connected because it's kind of it's our bread and butter. And I think this is fairly transferable to work. I don't necessarily think it's more like I don't necessarily think that this has to do with working in tech. I think it's just simply like working. If I think though working in tech has a little bit this component of competition amongst employees, and I think it's like a healthy competition, don't take me wrong, but like we are assessed against our peers and we kind of like get a grade at the end of the cycle. And I think that this part of competition goes really well with someone that has been an athlete, because I'm used to compete with my teammates in a healthy way. When you're a swimmer, like swimming, it's not like a group sport. So you're actually competing against your teammates, but you do it in a healthy way because these people are also your friends. So I think this is probably the most transferable skill in between swimming and tech, because this sort of like often assessment that we do, I think it's quite specific to like the tech industry or like certain industries. So definitely feeling comfortable competing against my co-workers at the same time that we work together and we develop friendships, it's something that being a swimmer taught me.
That's amazing. And I agree. I think competition in tech definitely exists in certain ways. And I think if it's done well, it can be, you can kind of compete up, right?
Exactly.
Everyone pushes themselves
Hmm.
and it can be an incredible source of motivation.
Yeah, exactly. I think
So
sometimes like competition is not seen as something positively or positive, especially on like the workplace. And like competition can definitely be negative, but it can also be a positive thing. And a lot of times I regard it as something positive that just like push each of us to be better.
I couldn't agree more. So let's segue into your role, your current role at Meta, right? In the introduction, I believe I called it a research data scientist. However, you don't, as far as I understand, you don't do fundamental AI research, right? So could you maybe explain what your role is?
Yeah, like research comes in a lot of different flavors. And one thing is like university research, which is this like groundbreaking research of things that don't exist yet. And you're going to develop them, call it like an algorithm or like a method to solve a problem or whatever. And another thing, it's like commercial research. It's like research that it's meant to generate like revenue or like a dollar impact. And this is like the sort of research that I do. What I try to do basically, I work in the ads space, and our ads ecosystem is a really complex ad ecosystem. Like there are millions of models and neural networks there interconnected, embedded in between them, and like that are fairly like complex to decipher, and even more for like a lot of our advertisers, which they are not necessarily like extremely tech savvy. So my role is to understand all these models in a lot of detail and try to translate certain characteristic of these models into marketing actions. So if an advertiser wants to acquire new subscribers, for instance, how they could do that in the best way using our models at their maximum capabilities. So this is like kind of like the sort of research I do. Like there is always like I'm always trying to answer a question that will help advertisers to optimize their performance using meta advertisement products.
Okay, okay, that's very clear. And so To go more into the details of that, could you so it's research that, okay, so it's not like university research necessarily. It's it's research of a dollar sign in it. You're helping advertisers at the end. But so can you walk us through, just at a very high level, the life cycle of a research project that you might lead, from the inception to, like, what does the finished product look like?
Okay. Well, we can think of like a specific example, but I think I would also like to take it from like a generic perspective, which I think might be more useful for the listeners. What we do in my team is every 6 months we do or we create the roadmap. Basically, the roadmap is just like a list of a list of projects that could be interested to tackle, and we generally like get ideas of this project based on what our stakeholders need. What does it mean? That maybe I'm gonna be meeting the head of industry for the entertainment and media vertical, someone that handles companies, let's say like Netflix or a Spotify, like these sort of companies, not that are in the entertainment and media vertical. And this person is going to tell me, look, the key goal of our clients in the next half, it's going to be to retain their subscribers. Which sort of strategies could we give them in order to retain these subscribers? And this question is a question that we're going to try to answer a lot of different teams. There's going to be the creative team that it's going to think about retaining subscribers by modifying the creative itself in the ad. But then there's going to be my team, which we're going to think of like which models should you be using? Which levers can you touch on your campaigns that will affect positively this idea of retaining subscribers? So, like, once we have this list of projects, we run through an internal prioritization on which one we are going to tackle. These projects are generally like fairly long, like they might take from 2, 3 months up to 1 year, depending on which is the outcome. So we will generally like prioritize them based on like how much revenue are we going to touch, how willing a certain cohort of advertisers are on like changing their behavior. Like, if we're going to produce recommendations, we want to produce recommendations for clients that we know that they are willing to change their behavior. And we basically like have these kind of like two main prioritization metrics, like money and behavior change, and we rank the projects. And then depending a little bit on which are our interests and which are our strengths, a member of the team will pick one project or another. Once we have this, there is probably like the part that it's more analytical of a project, that is which data sources are out there available for me. Which data, at the end, you are just like trying to to give an answer to the question of which data can help me solve that particular question. So a more kind of like a, excuse me, a more like analytical phase of the project arrives. And we basically spend like a lot of time querying data, building pipelines to, at the end, have a data set that will help you solve your question. Usually, like once we have the data set, then we go into more like the modeling phase. And if we think about like the question that this entertainment and media vertical lead told us, no, like I want to help my clients to retain customers, we can make something like some sort of like regression model trying to explain which are the different levers that a client can put on their campaigns that will effectively or that will lead to retain a customer for longer. No, and like then we might see things like, I know, targeting really broad helps positively retain customers. And this we will do it by using really likely like regression models, or models that kind of let you explain the variables. And then here, like, I would say that like the data science part of the role finishes. We have had this prioritization of the research question, finding the data, modeling the data, and then it comes more like probably more like the commercial side of my job, that is like, well, now I have some answers for the question that people want, but I have technical answers. How I translate these answers into actionable items for our advertisers. And here we work a lot with like other stakeholders that are really good at translating findings to advertisers, and we just try to build a narrative that it's gonna land well. to more like marketing oriented people. And this kind of like would be a little bit like the life cycle of a project. Sometimes on this life cycle, we have to introduce testing, for instance, because maybe we don't have enough historical data. And a lot of times, when you don't have historical data to answer a question, you need to create this data. And creating this data, a lot of times simply means like doing a test to be able to reject or accept the hypothesis that you want to like give an answer for. So like a lot of times at the end, like my research ends up being like, well, okay, I don't have a data set. I cannot model any data. I'm just gonna do a certain amount of tests, and from here I'm gonna do a meta-analysis, and this meta-analysis is gonna give me like a certain degree of confidence that strategy A is better than a strategy B, and this is what I will bring to the table of the advertisers. So this is kind of like probably like the two main ways we tackle the research, either by historical data or by testing.
Got it. And so, in the case of testing, that's really interesting. So, very clear. Right? You might not have enough. You might not have enough historical data to build a
Yeah.
model, and so you're obviously going to want to, do an A/B test or some sort of test to test out your strategies. But where does the hypothesis come from? That you're testing. Is it still data driven? Is it more by is your stakeholder suggesting it? Is there common work there?
Well, it's generally an in between. We generally have the research question coming from the stakeholders. And based on the research question and our knowledge on how our models work, we can translate this more business oriented question into something that can be tested by an A B test or an incremental test. So let's say if we go back to the example of I want to retain subscribers, we obviously cannot create a test on like how can we retain subscribers. So maybe we translate that into um, which campaign drives longer lifetime value for an advertiser, a campaign optimizing for subscribers or a campaign optimizing to reduce cancellations. And this is like the hypothesis. Like in that case would be like, okay, hypothesis A is that, or the hypothesis that we want to approve or reject is that optimizing to minimize cancellation drives like better lifetime value. So there is a lot of like business knowledge required to transform a business question into like a statistical test. But here is where like our expertise is required.
Okay, very clear. And then probably last question on this specific topic on the really on the question of the life cycle of a project is how, because when I think of research as, even in my role, right? Like it's a part of my time that it's something that's unsure. So there's a bit of a risk of me allocating time to do something. And so how do you define a successful project, and how, like, what does a successful project look like, and what does it mean for a project to be unsuccessful?
That's an interesting question, and it really it doesn't have an answer really. Success is defined in like a lot of different ways, and especially in research, like success is almost like impossible to define in a single word. I can give you an example. For instance, on my second year as a research data scientist in the team I am right now, I worked in a model that was proving to be like really good. Like all like we were passing all the tests like with like amazing success. It was so good, the model that we were developing, that we were productionalizing it. So like we were like building all the infrastructure to make this model available for advertisers. So everybody in my leadership was delighted. Then, given the ecosystem in the ad space changed, and as a company, we could collect less data from users due to the changes that Apple introduced, my model was not viable anymore. It didn't make any sense to go in that direction. So I needed to completely deprioritize the project. And deprioritize here, it's like hardcore deprioritization. Like one day we shut down the project. Um, this was seen still as a success from my team because we took a really high risk. We took a really complex um, business question. We translated it really well into like a data science or like a modeling problem. We were being really successful on like bringing a lot of X events together, or a lot of stakeholders together, a lot of engineers together. We were building like a really good product for our customers, but we just like simply like didn't make it to the end because it was not the right moment of time to like bring this model to production. But this was a success because as a researchers we did something that it's good. We did research, but the outcome of the research is not always going to be translated to like a dollar amount. Sometimes you're going to fail and sometimes you're going to succeed. So what I've seen in my team is that the most successful team members are the ones that sometimes fail. But because if you fail as a researcher, if you don't produce an outcome, means that you are taking risks and that you are tackling complex situations. If you are always able to give an answer to advertisers, if you are always able to like find a solution to your problems, that maybe means that your problems are too simple or that they are not ambitious enough. So I think at the end, what we value in a research team like mine, it's more the way or like the path and not only the end point. We don't care so much about the end point. And don't take me wrong, it's important. Like we're a commercial researcher and like our directors and our leadership need to make sure that we are producing research that drives value. But it's totally fine if not all our research drives value.
Okay, that's extremely clear, and it makes a lot of sense to hear you say it. I'm going to pivot the questions a little bit. So, when I hear research data science at Meta, it's easy, I think, to picture, complex mathematical proofs, dies and lives of Pythons, using GPUs to train neural nets. And you've kind of already hinted at some of the tools you use, right? Regressions with explainability. You've hinted at A/B tests as well. Could you just run a little bit? It can just be like a bit of a list, like some of the tools that you use on a day-to-day job, right? And tools could be programming languages, but it could also be like statistical techniques, just things that you find yourself using recurrently. I guess for phase 2 and 3, right? Once you have the problem and you're either building a pipeline or building the model.
Yeah, that will depend quite a lot on the project. I don't think we have like a set toolbox, but I think anyone that wants to be successful in a job like this needs to be extremely fluent with SQL. That's kind of like a must. You need to be really good if you want to enter to tech because our data sets are complex. Our data is not really well structured. And sometimes to build your, let's call it final data set, you're going to need to join 1,000 tables together. So you need to be extremely good at SQL. Then you need to know a little bit of like ETL. You need to know how to build pipelines. And in order to build pipelines, you need to know a bit of Python generally. So I use a lot of Python to build my pipelines that like are an in between. Like obviously, like some of the kind of the builders of the pipeline are coded in Python, and the transformer in itself, it's kind of plain SQL, PL SQL, or whichever SQL your company is using. Then the analytics part or data science part of it, it's a bit like free. You can use whichever language you want. I use Python generally. A lot of people use R. It's up to the person. I don't think we should go back to this kind of like R or Python, what's better? No, it's like I think when you reach a certain level, like you just use whatever you're more comfortable with. And certain things are gonna be done in an easier way if you do them in Python, and for other use cases, R might be better. In my case, I don't know R. I do everything in Python. I feel a lot more comfortable in Python, and like I've never spent the time to learn R, and I can perfectly do everything in Python. That would be like with regards of like programming languages. C++ or C or Java, it's not like required for the sort of work I have. And then in terms of like statistics, like well, all data scientists should be a statistician. So you need to know testing. you need to master testing. You need to know what it means to test incrementality, what's an A/B test, how you decide holdouts, what's a p-value, what are confidence intervals, and you need to be able to explain these things to like plain audiences. So I would say in a job like mine, statistics is key. And machine learning, well, it's basic because what I do at the end of the day is I try to explain really complex machine learning models into like plain English. But I'm not a neural network expert. I know what's a neural network, I know what's a convolutional neural network, what's a recurring neural network, but even now I wouldn't know like how to build a very complex like neural network model. I understand really well the theory of like sophisticated machine learning algorithms, but I don't necessarily know how to build these models. Um, and here like might be different to like other data science roles that maybe lean in are more like similar to like machine learning engineer roles. In my role, I don't really build models to predict so much. I build models to explain. So I'm a bit more maybe into like the statistics side of the spectrum of what's a data scientist.
Okay, that's very clear, and I think that'll be very helpful for people that listen. And if you feel like this role might be interesting for you, at least now there's a few check boxes. What to know, and also very importantly, what not to know. All right, I think we're coming up for time. So maybe very lastly, we started this conversation with sports, and I'm seeing a bicycle in the background, and so I think it's fair to end with sports. And so for those that don't know, you're a triathlete. You compete in Ironmans. Could you run through, like in one sentence, what's an Ironman? Kind of the distances involved, and then the obvious follow up. But I think it's going to be the same answer as the first question: is how do you juggle your career with Ironman trainings?
And Ironman is a really long triathlon for people that are really crazy. Like myself, you do like a 4K swim, nearly 180 kilometers in the bike, and a marathon, one after the other, all wet all day because you use the same clothes and you eat gels during 12 hours. This is like an Ironman in a nutshell. Sorry, my light keeps blinking all the time now. And yeah, I started doing that during COVID. Since I didn't have to commute or anything, I realized I had a lot of free time, and I think I chose the hobby that it's more time consuming. You have to train a lot of hours. Like I train an average of like 2, 3 hours a day, depending on the day. I think when we work, or like at least in the environments where I have work, I cannot make generalizations, but we have a lot of time. If you organize well your day, if you are efficient when you work, we have a lot of time. Yeah, I don't wake up at 7. I wake up at 5:30 some days, and I do my first training before work. Then I work all day, and I do another training generally when I finish work. And why I can juggle this? Well, first I work from home majority of the time, so I don't have to commute up and down. That gives me a lot of extra time to train. And also, like, training is my priority in life. It's what I want to do after work. It's my hobby, and it's time for me. So I will always prioritize training after work. Obviously, family goes first, and work is important. But like sometimes I might reject a meeting if they put a meeting at 7 p.m. because 7 p.m. is my training time, and I love doing it, and it's what gives me energy. And at the end, being happy and having this really strong hobby makes me a better employee because it makes me more efficient of my time. So yeah, I think it's really similar. Like it seems like I'm closing a bit a circle. I'm going back to the way I was when I was a little kid being an elite swimmer. But I'm not an elite triathlete. It's a bit more amateur now, everything.
All right. Well, thank you so much for coming on. Best of luck with both the triathlon and the research. And yeah, thank you again.
It's been a pleasure being here.
All right.
Thank
Bye.
you.